Hello everyone and welcome back. In this session, we will talk about the classification methods. There are different classification methods which you can find here in the method box. Let's explore some of them and see how they affect our data visualization. The natural breaks or Jenks method identifies natural groupings in the data values. This classification is based on the Jenks natural breaks algorithm, and it minimizes the variance within each class and maximizes the variance between classes, creating a map that emphasizes the inherent patterns in the data. For example, if we're mapping population, natural breaks highlights counties with a higher number of populations distinctly from other ones. For example, here, Los Angeles County, with 10 million population in California, is highlighted on the map. Remember that you can change the number of classes and also modify the upper value of each class based on your requirements here, under the Classes tab. When you are changing the upper values manually, then the classification method gonna be shown as manual interval. In Symbology pane, the normalization option allows you to adjust data values by a specific field, such as using the area to show population density, which normalizes the population by the area's size, to represent population distribution across regions. For this exercise, let's select the natural breaks method with 5 classes, and change the normalization to none, and change the format of the color scheme. After finalizing the symbology, rename the layer to the natural breaks, and then create a copy from it and paste it. Then, rename the new layer to Quantile classification. This time, let's try the Quantile method with 3 classes. The Quantile classification assigns an equal number of data values to each class. This method is useful when you want to ensure that each class appears equally on the map, which can be helpful in highlighting data distribution. For example, if we have 3,221 counties, and divide them into 3 classes, each class will contain approximately 1,074 counties. To verify this, let's query and select counties with a population of less than 15,259 people. The 15,259 number is based on the range value from the Quantile classification. The selection query shows that 1,074 counties are selected. The selection results show that there are 1,074 counties have a population less than 15,259. Let's get another query to find counties with a population of more than 15,259 and less than or equal to 45,709. The selection results show that there are 1,074 counties that have populations within the same range. If you multiply 1074 by 3 classes, you get a total of 3,222, which closely matches the total of 3,221 counties in our database. Before using this method, you need to have a specific reason for using the quantile classification. So, be careful about using this method. The resulting map can often be misleading because similar features can be placed in adjacent classes, or features with widely different values can be put in the same class. You can minimize this distortion by increasing the number of classes. Before checking the next method, let's check the swipe tool. When you have multiple layers, you can use the swipe tool to compare layers. Here, for example, you can compare the top layer versus the second layer that is active on the contents pane. Let's create a copy from this layer and paste it into the contents pane. Then, let's rename the new layer to equal interval. Here, in the method box, let's change the method to the equal interval. Equal interval divides the range of data into equal-sized subranges. This method emphasizes the amount of an attribute value relative to other values and highlights outliers. For example, when the population ranges from about 100 to 10 million, and we choose 5 classes, each class will cover a range of 2 million. Remember that the equal interval is best when it is applied to data ranges, such as percentages and temperature. Let's create a copy from this layer and paste it into the contents pane. Then, let's rename the new layer to standard deviation. Here, in the method box, let's change the method to the standard deviation. The standard deviation is another method of classification that shows how much a feature attribute value varies from the mean. The mean and standard deviation are calculated automatically. This method is good both for normal and skewed data, and it is effective in highlighting how extreme values differ from the average. For instance, we can see which counties have populations significantly above or below the average. Before continuing to the next session, let's turn on the natural breaks layer to highlight the distribution of the population and turn off the other layers. Let's review these classification methods. Then, in the following video, we will explore how to modify legends in ArcGIS.